Sample problem 23.02. A non-uniform electric field is given by E vector, which is equal to 3x I cap plus 4j cap, pierces the Gaussian cube as shown in the figure, where E is in Newton per coulomb and x is in meters. What is the electric flux through the right face, left face and the top face of the Gaussian cube? So here in this diagram, its respective figure is given. So we have the Gaussian surface in the form of cube, and this Gaussian cube will have 6 sides, and the edge length of the Gaussian cube we can find from this number, right? Because the starting edge is 1 meter and the end of the edge is 3 meter. So when you subtract 3 with 1, we can easily find the edge length of the Gaussian cube, right? And here in the Gaussian cube we have 6 sides: top, bottom, right, left and front and back side, right? But here we are going to consider only 3 sides of this Gaussian surface, and we are going to find the flux only from these 3 sides. What are the 3 sides? Let's see this diagram here. So we are going to find the flux through the right face of the Gaussian cube, and we are going to find the flux through the left side of the Gaussian cube, and we are going to find the flux through the top side of the Gaussian cube. Clear? So now let's rewrite the given first. What is given in this question? They gave the electric field equation. What is the electric field equation? E vector, which is equal to 3x I cap plus 4j cap, and the unit for this is Newton per coulomb. Now what I'm going to do, I'm going to apply the rule for finding the flux. Actually we have 2 rules for finding the flux. Flux phi, which is equal to electric field multiplied by area, and also we have another rule, phi, which is equal to the charge enclosed in the Gaussian surface, or the charge inside the Gaussian surface, over epsilon naught. But for this question we cannot use this one because the charge information is not given, so I am going to use this formula for this question. So now let's go one by one. So first I am going to find what is the flux coming out of the right side of the Gaussian cube. Clear? So let's write the given one more time. So electric field vector is given here as, I just go back, so 3x I cap, 3x I cap plus 4j cap, Newton per coulomb is the unit for electric field. Now I am going to consider only the right face of the Gaussian cube. So for that I have to use the rule phi, which is equal to electric field multiplied by area. So here electric field equation I can directly substitute. I'm going to take this, I'm going to substitute this one here, and this is E dot A, right? So E dot A, which is nothing but EA cosine theta, but I'm not going to use the angle here. So we just use A dot A. So I'm going to write the equation of the electric field vector equation, which is 3x I cap plus 4j cap, and this is the dot product with the area vector. Area vector is very, very important because we are going to consider the right face. Am I right? So this is the right face of the Gaussian cube. So here you can see this is the area vector of the right face. So here you can see the area vector of this right face is exactly pointing towards the positive direction of the x. So we have to mention with the unit vector of I cap. So how can I write? We can just write this as area vector multiplied by the positive value of I cap. Why? Because you can see here your area vector from the right side, the normal of the right face is perpendicular. It's exactly towards the positive direction of the x. So the positive direction unit vector is I cap, right? So I have to multiply A with I cap. Now what I'm going to do, I'm going to use the dot product for the multiplication, because we studied in chapter number 3 vector, where the topic is vector in physics 1. So I have to multiply I cap with I cap. So if you multiply I cap with I cap, what you'll get? I cap with I cap only we will get the answer. If you multiply j cap with I cap, it becomes 0. So we consider only I cap. So 3x multiplied by area, and we have to multiply I cap dot I cap. So what's the formula? What's the value for I cap dot I cap? We studied I cap dot I cap, which is equal to 1, j cap dot j cap, which is equal to 1, k cap dot k cap, which is equal to 1. So here we are just going to consider only I cap dot I cap, which is equal to 1. So now I dot I becomes 1. But the most important thing here, we have to consider the area. How to find the area? We just go back to the diagram. I have to find the edge length. So I have to find this value. How can we find? So 3, so area we can find later. First we can find this edge length. So the edge length here is 3 meter minus 1 meter. So 3 meter minus 1 meter, which is equal to 2 meters. So this is the edge length of the cube. So the formula for area is length into width. Am I right? So here in cube all sides are equal. So the length, which is equal to the width. So we have to multiply 2 meter multiplied by 2 meter, which is equal to 4 meters square. So this is the value for area. So now let's substitute the value. And also the most important thing, we consider only the right face of the Gaussian cube. So what is the corner value of this Gaussian cube? You can see here the value of x here is 3 meter. So what I have to do, I have to substitute the value of x here. So if this value x equal to 1 means, what is this? Because this is the value for the right face, x, which is equal to 3 meter. So I have to substitute 3 here. So 3 multiply with 3 for x, and the area is 4 meter square, and I dot I becomes 1, and then the unit for the flux we have to write. So what is the unit for the flux? Newton meter square over coulomb. So if you multiply, we will get the answer. 3 multiplied by 3 is 9. 9 multiplied by 4 is 36. So 36 Newton meter square per coulomb is the answer for the flux, which is coming through the right face. So this is the answer for the first part, which is A part. Likewise, we have to do the same thing for the left side. So let's consider this diagram. I'm going to use the same rule. So better I can make the partition here. So I'm going to consider the left side, and the edge side is x, which is equal to 1, and this side is 3. So I have to do the same thing for B part. 3, which is equal to E vector dot A vector. So if you substitute the E vector value, which is given in the question, 3x I cap plus 4j I cap, dot product with area vector. So we consider only the left side of the face, and you can see the normal of the left side is pointing towards the negative direction of the x. So we have to write area multiplied by negative of I cap. Why negative of I cap? Because the area vector pointing towards the negative direction of the x. So now I have to multiply. If you multiply, what you'll get? We have to multiply only with the I cap with I cap. So 3x multiplied by area multiplied by I cap dot I cap. So I cap dot I cap, which is equal to 1. So we have to substitute 3 multiplied by, and the corner of the left side is x is equal to 1 meter. So 3 multiplied by 1, and the area of this cube is 4. So 3 multiplied by 4, we got the answer. And the most important thing here, we did not have I dot I, which is I dot minus I. So that means we have to multiply with minus 1, because I dot I is positive value of 1, but I dot minus I gives the value of minus 1. So we will get the answer. 3 multiplied by 4 is 12. 12 multiplied by minus 1 is minus 12 Newton meter square per coulomb. And this is the answer for the flux through the left face. This is the answer for B part. Clear? Now we have to come for the top face. So we have to consider this diagram. So now we have to see which direction our area vector points towards. So you have to see the axis, x-axis, y-axis, z-axis. So here the area vector pointing towards the y-axis. So that means the positive direction of j cap, right? So now again I'm going to use the same rule, P, which is equal to E dot A vector, and E vector, which is nothing but 3x I cap plus 4j cap, which is given in the question. And here the area vector point towards the positive direction of the y cap, y-axis, which is nothing but plus j cap. So now I have to multiply j with j only, because I dot j becomes 0. So we can multiply only j with j. So 4 j dot j. So j dot j becomes 1. So we have to substitute the value for area. So area, which is equal to 4 multiplied by 4, and j dot j becomes 1. So we will get the answer for the flux from the top phase, which is 16 Newton meter square per coulomb. So this is the answer for the third part. Clear? So we have to be very careful. We have to multiply only with j, I with I. Clear? So 4 we already have, and then 4 is the value for area. Once again, I will show you the value for the area. So we already calculate the area here. You can see first we have to find the edge length value. So this, if this is length multiply with is the area. So 2 multiplied by 2 is 4. So that's the reason for area we substitute the value for 4. So this is the answer for the third part. That's it. Thank you.